All right, class. Today we're going to continue talking about chemical reactions. If you remember, we started talking about them last class. To experiment with this further, we're going to be doing, looking at a reaction between two common household ingredients. So here we have vinegar. It's also known as acetic acid. And here we have baking soda, which is also known as sodium bicarbonate. So, as good chemists, we have to make observations. What observations can we make about vinegar? Here, I'll pass it around so everyone can take a closer look at it. Go ahead and just shout them out when you think of something.
It smells like salad dressing.
Yeah, definitely.
It's clear.
Perfect.
It's all liquid.
Yeah, exactly. So, what are all of our states of matter, if we remember from last time?
Solid.
Yeah.
Liquid.
Perfect.
Gas.
Yeah, exactly. And what sort of observations can we make about baking soda?
It's white.
Mm-hmm.
I use it to make chocolate chip cookies.
Yeah, perfect. Me too.
It's a solid.
Exactly. And another thing, a side note that you want to keep in the back of your brain for next class is here we have an acid, acetic acid, and here we have a base. And so when we mix an acid and a base, usually we get a pretty crazy reaction. And we're definitely going to get to see that today. So, as I mentioned before, we're going to be mixing the two of these together. Do we have any predictions on what do you think is going to happen? Go ahead and write them up on the board. Balloon is going to expand and pop. All right, that's definitely an interesting prediction. Does anyone else have any other predictions? Yeah, Karina, go ahead and write it up on the board. So we think the balloon is going to expand, but it won't pop. That's another good prediction for sure. Liz, do you want to write your prediction up on the board? So Liz thinks the balloon and bottle will blow up. That would be a pretty crazy reaction. So we're definitely going to see what's going to happen. But I want to know, Delaney, what makes you think that the balloon is going to expand and pop?
Well, if the reaction is big enough, but the balloon isn't as big or it's too small, then it's just going to pop.
Yeah, for sure. That's definitely a good rationale for your prediction. So are you guys ready to do kind of a friendly competition? Let's see whose balloon is going to blow up the biggest. All right.
I don't know. I think it'll be mine.
Here are some bottles. If you notice, there's a little bit of vinegar in the bottom. That's not water, so don't try to drink it. And then we have balloons, and those already have the baking soda in the bottom. So we want to be really careful not to tip it in to the bottle when we're putting it on top of the balloon on top of our water bottle. So you want to stretch the bottom part of the balloon over the bottle and wait until I say go to tip it upside down. Does everyone have theirs on? All right, now we want to make sure to hold it on really tight when this is happening so that the balloon stays on top. All right, on your mark, get set, go. Whoa, you can mix it up a little bit to help it happen even faster.
Still going.
Yep, if you can hear that fizzing, the reaction's still going on.
Look how big my balloon is.
Yeah, good job. Pretty cool. All right, if you want to keep your balloon, you got to take it off the top of the water bottle and tie it up. That's a little tricky. Okay, there we go. All right, nice job, everybody. Okay, so now that we had our reaction happen, we got to see it in real time, what do we notice about the balloon after the reaction?
It's filled up.
Exactly. So how could that happen? We had a deflated balloon, we put it on top of the bottle, and now it's all the way filled up. How could that happen? Yeah,
Did the solid and liquid turn into gas?
exactly. That's definitely a really good observation, and you're exactly right. So if you guys notice, we started with a solid, a liquid, and now we have a gas. Ooh. So that teaches us that our reactants can turn into any state of matter after the reaction happens. They don't have to stay in the same state that they started in. And we also notice, you can probably still even feel it, if you touch the bottom of your water bottle, does anyone notice anything about it?
It's colder.
Yeah, it is colder. So if we know that heat is a type of energy, and we're losing heat in our water bottle because it's colder, what could that tell us about our reaction?
The reaction used energy?
Exactly. So that means our reaction between baking soda and vinegar is using up energy, and it's taking heat in. This is what we call endothermic. That's going to be a really important term to remember. This means endo, taking in, and thermic is a word we use for heat. So a different type of reaction might feel hot to the touch, and that's something we would call exothermic. Exo means out, and thermic means heat. So another thing I want to point out is here we have the same amount of elements on this side and on this side. And if we weighed the weight of this, it would equal the weight of this. And that teaches us about the law of conservation of mass. So no matter what reaction takes place, we're always going to conserve the mass. No matter what, it's not going to take it away, it's not going to gain mass. It's always going to be equal. It's something that you're going to want to remember. Another thing I want to ask everyone is, whose balloon floats? Why don't we go ahead and try it out?
Mine doesn't. Mine doesn't.
No, it sinks. It sinks pretty fast. And so we have a balloon filled with a gas. Who can tell me what gas is filled? I have a reaction written up here. Anyone know? Yeah, Delaney.
Carbon dioxide.
Exactly. So we have a balloon filled with carbon dioxide. We have a room filled with air. That must mean that carbon dioxide is heavier, or for gases we would call it denser, more dense than the air around us. Do we have any other questions? Yeah, Karina.
What makes balloons float then?
Sure. Okay, that's a really, really great question. So the balloons that we have at a birthday party that are floating up in the air, they're also filled with gas. But we have a balloon filled with gas that is sinking. So a clue is it's filled with a different type of gas. And the specific type of gas that I'm sure you have all heard of before, it makes your voice kind of funny, is, does anyone know? Does anyone remember?
Helium.
Yeah, exactly. So it's helium. Helium is extremely light. So it's even, air is actually more dense than the helium. So the helium is able to rise up above the air. So that's how we have Barty balloons that float. So pretty interesting. That's a great question. Does anyone else have any other questions? Yeah.
Would the different sized bottles make for different reactions?
Oh, that's another great question. So the different size bottles aren't necessarily going to affect the reaction because we have the same amount of baking soda and we have the same amount of vinegar in each one of our reactions. I made sure to measure them out correctly. So the only thing, the different size bottles might make for different size balloons. And that's only because we have different shaped bottle, different amounts of space inside the bottle. So some of the gas can just stay right inside the bottle and it's not forced into the balloon. So that's how we have maybe Delaney's balloon is a little bit smaller than than Karina's balloon, which it's just because you have different sized water bottles. If you notice, Karina's balloon, or Karina's water bottle is actually pretty small. So we had a lot of the gas being pushed into the balloon, and that's how her balloon got so big. So yeah, anything else? No? Great. Great job participating today, class. All right. Yeah.